Dr. Katrina Merkies is a researcher and associate professor at the University of Guelph. She has conducted various equine behavior studies, including the one we're going to talk about today, which quite literally gets inside heads of horses and donkeys for comparison. Welcome, Dr. Merkies, and thank you for joining us.
Thank you. It's fun to be here.
Can you briefly describe your research project and how it came about?
I had the opportunity to do some sabbatical research with Dr. Paul McGreevy in Sydney, Australia. And I was interested in looking at neurological basis of behavior. And Dr. McGreevy had an ongoing research study looking at skull morphology in dogs. And he was interested in expanding this research to horses to determine if there were breed differences in skull morphology that were perhaps then linked to underlying brain structure. So that's how this research project came about.
I understand that this type of research has been done in dogs before, but not so much equids.
This was the first study that I know of that looked at comparing skull morphology in different horse breeds.
So what did you expect to find?
This was started as an observational study to explore horse skulls and brain morphology and to see if we could find any breed differences. So originally we wanted to look at various breeds of horses, cold-blooded versus hot-blooded breeds in particular, but it was difficult to obtain sufficient numbers of horse skulls. Standardbred skulls were what most often came to us, and these were horses that were euthanized for reasons completely unrelated to the study. So we had a connection with a local abattoir, and we were fortunate to make use of these horses. But we were only getting standardbreds, so we weren't really able to look at any breed differences. So then Dr. McGreevy was talking to colleagues who hooked him up with Dr. Parachute, who worked at the Donkey Sanctuary in the UK. And he was doing the postmortems on the donkeys there, and he was happy to collaborate with us. And he took photos of the donkey skulls that he sent to me, and then I was able to do the analysis on them, and then we could make the comparison between standardbreds and donkeys.
And what is the significance of this discovery of different size and placement of olfactory bulbs in horses and donkeys? I understand that was one of the discoveries.
Absolutely. We found that the olfactory bulb in donkeys was smaller than in horses, and it was rotated more inward toward the center of the brain than in horses. And the olfactory bulb is important in processing external stimuli that are related to smell. And the olfactory bulb is also linked to the amygdala, which is the center in the brain related to memory and emotions, associated with smells. And the amygdala is also important in associative learning. It is likely that the larger the olfactory bulb, the more sensitive that animal is to a wider range of odors. So perhaps horses have a better sense of smell than donkeys, but this is not proven. How the size and location of the olfactory bulb may influence smell, learning, and memory among different species will certainly be interesting to explore in future studies.
And I also understand during the study there was some interesting correlations relating to whorl placement. Can you elaborate on that?
At the beginning of the study, we weren't looking at hair whorls at all. It was only as I was placing pin markers on the skull landmarks to be able to perform the various skull measurements that I noticed that I most often was placing the pin directly on or very near the forehead whorl when I was marking the location of the olfactory bulb. And I thought that was kind of cool. So I went back and analyzed all the photographs I had taken of all the horses to be able to corroborate this finding. And it turned out that indeed, wherever the olfactory bulb was located did correspond very closely or exactly to the location of the forehead whorl. When I moved on to the donkey skulls, I immediately noticed that they don't often have a forehead whorl, and instead their hair whorls are located much farther down the nose. So there was no correlation to the olfactory lobe location in donkeys.
There's some folklore behind whorls, isn't there?
Yeah, the location of the whorl has a place in folklore. As you said, a whorl located above the eye line indicates a more high-strung horse, while a whorl located below the eye line means a calmer horse. And this has been documented in cattle, but I haven't found any clear scientific evidence of this in horses, but it does quite match the findings that we had. With donkeys, their whorl is located very far below the eye line, and this matches well with their known temperament, which is calm.
And what are the potential practical applications of your research for those who own equids?
These research results underline the importance of noting the differences between donkeys and horses. Although they both belong to the species Equidae, there are profound differences between them, and they should not be treated and managed in exactly the same way. Seeing differences in their brain structure and in external skull conformation supports this. And then I mentioned the location of the whorl, so paying attention to where the whorl is and understanding that that may well be linked to temperament.
All right, thank you, Dr. Merkies. In closing, is there anything you'd like to emphasize or sum up or take a glance into the future of behavioral studies?
My research program focuses on the behavior and welfare of horses and spans a wide range of topics, from the one we just discussed to on-farm welfare assessments to horse-human interactions. And there's just so much to discover about horses, and I hope that my small efforts can lead to a better life for horses.